learning in science in K through 5, which is a very important effort if we're really going to support kids in really trying to develop the deep knowledge they need to solve the pressing problems that exist in our world today with respect to science. If you don't know me, I'm Joe Krajcik. I'm the director of Create for STEM Institute here at Michigan State University, which is an institute that's dedicated to improving the teaching and learning of STEM K through 16 through innovation and research. It's supported by our provost office, and it's a collaboration between the College of Natural Science, College of Education, and College of Education, really try to improve the teaching and learning of science. To begin, if this thing works, can I get to turn it on? Oh, it is on. Okay. Well, the clicker's not working, so can you go forward, brief? Thank you. So, right, I introduced myself. Hi, I'm Joe. Can we go on to the next slide? Thank you. And I first want to begin by acknowledging that Michigan State land really exists on the property of some indigenous tribes that used to live here many years ago, and we certainly want to respect this place for this. And hopefully we as humans that are here now will respect the land as much as they did and can pass it on to others as we grow older. So you need a tech guy to learn how to do all this stuff. Okay, great. So what's the purpose of today? The purpose of today is really trying to bring us together to explore how more teaching and learning can actually occur in K through 5, and really make it a collaborative, make it a joint venture, or how we can really integrate stuff to really promote learning. And particularly, we need to realize that most of the disciplines that live out there, actually, that we teach, work together. Do we need to learn how to read? Absolutely. I am an avid reader. Do we know how to do we need mathematics? Absolutely. I can do math. I still do mathematics without my calculator. But do we need science? Absolutely. And those subjects all work together to really support us to develop the knowledge we need to live in today's society, to make sense of all the claims that we hear, and to wonder, do we really have enough evidence to support that claim or not? So today's event is really trying to explore how we can integrate, how we can do more teaching and learning of science at the K-5 learner, but do it in an interdisciplinary manner so kids really come away with really strong knowledge in the various fields. And of course, we have planned for you today a variety of different activities, everything from work at your tables to hearing some keynote speeches by a variety of different individuals. I really want to thank a variety of different organizations that really supported this event. This was not a one organization event. Teams, groups from throughout the state came together to really put this event together. And I have to tell you, they worked diligently. They met weekly, they talked, they argued, and they put this event together. And it's really impressive that we see on a Wednesday morning, the number of people are here because we are so concerned with the teaching and learning of science in K-5 education. Next, I can go forward. I also want to thank a variety of different people at the University of Michigan that really helped, at Michigan State University that really helped do this, and particularly, I don't know if you don't know it, I lived at Michigan for 25 years, so I always make that slip. I'm sorry, Phil. It was Michigan State that really helped support this effort. I particularly want to point out the Provost's office, the College of Education, the College of Natural Science, and the College of Engineering that really supported this very generously to allow this event to occur. I actually do have, you always have, as director, you always have these wonderful responsibilities you have. So I have these great responsibilities, like, where's the bathroom? So the bathroom, women's are right this way, and the men have to go down the stairs and come back up. Lunch, there's a lot of people in this room, and so in order to make it more organized, lunch will be by sections, right? So people will come around and direct you who should go. I really want to thank a couple of people, and particularly I want to thank Corey Miller, I want to Renee Baer and Sue Kader, who are all back here, who really worked tirelessly in putting this off. Now, it's always a little fearful about naming a few people because there's other people who also contributed immensely to this. So I want to thank everybody. It's just I can't remember everybody's name that helped out. And finally, I want to thank Ted Manco. Where's Ted? Anyways, you'll see Ted. There he is. Ted's back there. Ted actually gave up his day to be here with us to take pictures of our events. So let's thank Ted for volunteering to take the images. And again, without the volunteer time of so many people, this would have never happened. So I really want to just thank everybody for doing that. Now it's my distinct honor to introduce the Dean of College of Natural Science, Phil Duxbury, who, again, the College of Natural Science really supported generously this event. And you can ask why, right? Why would College of Natural Science, and it's not education, you would expect the College of Education, but the College of Natural Science, why? And that's because we're never going to have the pool of people we need going up through the pipeline to really support the teaching and learning of science if we don't have kids in elementary school learning science. So it's with my distinct pleasure to introduce my colleague, Dean Phil Duxbury, to speak and give us a couple of opening words. Phil?
Good morning. It's great to see you all here. And STEM education is our thing in the College of Natural Science. And we are one of the world leaders and a leader in the US in evidence-based STEM education. So we have people that are doing STEM education research in many of the fields of science, ranging from earth and environmental sciences to chemistry, physics, biological sciences. We also have experts in mathematical sciences. And one person you may have run across or heard about is Betty Phillips. And she has a group that runs the Connected Math program that circulates the Connected Math middle school math textbooks. So one thing that is going to happen in the fall this year is the 4th edition will begin to be circulated. So the last edition was initiated maybe a decade ago, and we're very excited about the rollout of the 4th version of Connected Math Project. There are also a lot of the faculty that work in disciplinary-based education research that are passionate about transferring what they're learning into K-12 education. So people like Melanie Cooper and Danny Caballero, they actually collaborate with the College of Education for teacher training programs. And I believe, and we're struggling with many of the same things that K-12 education is struggling with, including quantitative skill development. And getting those quantitative skills is essential for a successful career in STEM. When we bring students into Michigan State University at the moment, we're finding that less and less of them have the quantitative skills they need to really enter the mainstream of our programs. So we have a lot of people taking, like, Introduction to Algebra at college, and many of them are not making it through. And it's worse for students from underrepresented or disadvantaged backgrounds. So we have this double challenge, and I think it's partly brought on by COVID, partly brought on by the fact that students somehow are not as interested in engaging these quantitative learning. So this group is at the front lines of that. How do we develop the skill sets that these students need to have once they get further along in their education? So thinking about elementary school science is absolutely critical. How can we amplify that? And how can we amplify the learning, the quantitative learning that students have? So we have 2 centers that are joint with the College of Education. As Joe mentioned, we have Create for STEM, which Joe leads, and Joe is a fantastic influence on our campus, as well as doing all the things he does in K-12 education, and his book, Interactions, which is high school science. He has had a great deal of influence on all of the disciplinary-based education research on campus, running some of the leading searches that got us the world leaders in some of these chemistry, like, for example, chemistry and physics education research areas. So Joe is a great leader of the Create for STEM Institute, And then we have Betty Phillips, who's part of the program in math education, which graduates people working in math education. And so those two areas are very strong in our college. We are also one of the leading research colleges at Michigan State, and it's across all branches of mathematics and science. We bring in something like $80 million a year in research dollars to do work in these various science areas. So one of the things we'd love to do more of is somehow translate some of the ideas that are emerging from our research into K through 12 schools. I think it's really important for students to kind of get a glimpse of the forefront. There's some that are very interesting and it'd be great to translate. There are some that are absolutely transformative things that you're probably starting to hear about. So artificial intelligence, what is that going to do to our education? And I think it's, things like ChatGPT, we're being very heavily impacted by that. On campus, we have to change the way we teach because the students all have access to ChatGPT and they're probably more facile with it than the instructors are. So we have to figure out how to train our instructors so they understand what the students can do with ChatGPT. But we also have to educate the students about what AI is going to do the workplace 10, 20 years from now. And what it's doing really is changing what we need to teach because a lot of the kind of transactional details of math and science can be done by artificial intelligence. So we have to work towards more conceptual learning. And that's what we do with disciplinary-based education anyway. We're always trying to build frameworks so people understand what science and math looks like, how it's structured, how it's framed, instead of just concentrating on details and facts. This is going to impact K through 12 education, as you're probably aware, and so we want to understand what you guys and other teachers need to learn about artificial intelligence and how we can help make that transition to a new world where artificial intelligence is maybe embedded in every school. So as well as the software side, ChatGPT, for example, there's also another very transformative thing that's happening, and you've probably seen this on the news as well, and that is we're getting robots that are mobile, that are humanoid-looking, and that they're being put into various workplaces, for example, in health in Japan. You can now get screened by a robot. So what's that going to do to our schools, and what's that going to do to our on-campus teaching? That's not far off. That's about a decade away, and we have to start to respond. So we're thinking about all of these things, which are transformative new things that are happening in the education sphere. They're kind of freaky in one way, exciting in other ways, like all major transformations. And again, you guys are on the front line. What we have to avoid conceptually is the concept that robots will replace us. We don't want that concept. It's going to be a case more of how can we use robots effectively to enhance education. So it's great to see you here. Threw out a few ideas, few thoughts there. We'd love to engage with K through 12 teaching more, and there's lots of ways we can do that. I hope you have a great conference thinking about elementary school science, and that you think about concepts and things you'd like to learn about that maybe we can help with, and we'll do whatever we can to do that. So thank you very much, and welcome again.